Okay, so this is my ENME351 Lab 9 final project, and for this one I made a Labyrinth powered by 4 stepper motors. Hey, what's up? So, as you can see here, it's going to be all controlled by this analog dual potentiometer and 4 stepper motors with linear actuators that I've 3D printed. Here's how it works. So here's start and end. And you have to go through this whole course without falling through the holes. So if I was to turn this, then you get to see that the stepper motors actuate in such a way that tilts the labyrinth the way I want it to. So if I was to tilt this downwards, this went down. Anyways, so I'm going to try to complete this course. I already failed. It's hard to record and complete the course at the same time. I'm just going to keep. There we go. But you can control it pretty accurately. It's just pretty hard. Here we go. Go up. To the side. Okay, there we go. Nice. I'm pretty good at this. Alright. This one's the hard part. Oh. There we go. And the hardest part of all is this little corner right here. Just gotta... And that's it. Didn't quite get it. Okay, first let's go over how this piston works. So you can see right here there's a servo motor, the lever arm, the pin, the piston, and the box. So when I actuate the servo motor, it'll flick this lever arm around, which will then move the piston up and down. Right now it's turned on, so I can't really move it, but if I adjust the potentiometer, you can see that it's just moving up and down. So next, I also had to adjust the piston right here so that there's a system between the interface of the labyrinth and the pistons themselves. So I made sure, since I didn't want any rubbing between the two plastics, I added a scoop to each of the corners of this labyrinth so that it would fit nice and snug with the ball bearings. So there you have it. It goes on top, and you're able to control it. So here is the code that I've used. I got it from robojax.com, but pretty much what the code is it makes use of the servo.write function. And yeah, the only modifications that I've had to make was increase the number of servo motors and have each of the servo values correspond to a different position on the analog stick. And so I really like to consider that there's 4 positions on an analog stick. Up right, or up left, up right, down left, and down right. So each of those corners correspond to a different minimum value of the servo motors. So you can see when I go up left that this goes down the most out of all of these. Inversely, if I go down right, then this goes down the most. So here is the code that I've used for processing. It's pretty much going to visualize the position of these pistons using the size and color of 4 circles. So you can see the code right here, and you can see it creating just 4 ellipses, and each of their sizes and colors are varied by the potentiometer values, which are exported from the Arduino file, or the Arduino code. So if I play it, you can see that there are 4 circles, and their tilt is indicated by the size of the circle. So a large circle means an extended piston, and a small circle means a retracted piston. Anyways, there's that.